classify and better organize our data, we must set into a data frame, or it's called the objects. It's a kind of heterogeneous data type, which means that it can store columns with different data types. Unlike the array that only can form with a single type of variable data frame. So here in this our lecture, we will explore more about the objects, and as we know, there are multiple data frame. First of all, we have single dimension, and also we have the two-dimensional arrays. In our last lecture, we stopped here at this command. Is the sum that we stopped here. We discussed about the sum dice and how we operate the roles. For example, if we're just rolling a dice, and what's the value that we will obtain by rolling dice 100 times. So we'll run this command and we will have like this value of 331. Now if we need to store this value into a variable, so we can basically type A, then assign it to sum dice 100. So in this way we will store the result in the variable A. So if we click A, we get the value right here. But I'm wondering why we have different. So if we click sum dice, run it, we have, because it's consistent, give us different value. Now if we need to take division, we divide the variable A, so we can insert the average after we store the value. We just divide it by 100, then it will give us the 3.59. As we discussed earlier, that the objects in the RStudio consist of 3 points. First of all, we have the data frame array matrix. So now we want to export the data frame from an RStudio, okay, but this is an incorrect way to run it. Instead, we will have to put the $sign right here, and we can type the iris, and this is where our file was stored, or the name of the file is iris. So this is much organized way, and this is the correct way to do it instead of just typing table, because this one is incorrect, or may it give us this warning message. Secondly, now for specifically making a single type of array, we need to set the value, the B, assign it to sequence of 1 to 24. Okay, then we have to also type this command, the Dempsey, assign it to length, then the matrix. This is just stating that it's from 1 to 24, and this is matrix, okay, that has 2 rows and 3 columns. Okay, after that we type, this is also another matrix. If we run this command, simply it gives us 1 to 24. We have the values 1 to 24, and we have the n numbers of rows and 4 columns and 2 metrics. Let's see if we run this command. It's easy, 1 to 6. We have number of rows and number of columns. Okay, so this is in order for us to specify if we need in the second row and second column, we need the value for it. So this is the way how we type it. We just click the shift sign, or we open the braces and click the 2. Also, we can write it in different way. If we run this means it will give us the whole values of the column. So this is the difference between making these two commands. Now, if we need the binomial. So first we need to assign the trials. We have number of 1000 trial, then we assign, okay, assign it as a binomial, R binomial. Then this is the n. Then we have the size, which is 1, and the 1 mean it's a 1 coin, and 0.5 is the probability of 0.5. Then we have table, heads, and or in this way we can run it, and it gives us like, this is just an example. If we need to see heads of 30 trials 30 times, this is how it runs. So now if we need to run a matrix with a uniform distribution, okay, first of all, since it's a matrix with two column, here's the rows, 2 rows. Yes, this is the number of rows. Okay, with 2 rows or 4 rows and 2 columns. I mean, let's assign it. Okay, so we have the 2 column and 4 rows. This is how, if we move into assign a uniform matrix with 4 rows and 2 columns and the uniform distribution. And we also need to, for example, to name both the rows and the columns. For example, 1 to 4, sequence 1 to 4 for the X and Y. So this is 1 to 4. And also we have the columns all, columns and rows all are named. And also if we need now to set the max and the lower value. So in this matrix we can see we assign it 5 is the max value and the 1 is the lower. So in this matrix we have 1, 2, 4. Like this is how to differentiate between the first or the second matrix.
So in this video we will be doing article 1.8, which is arrays, data frames and lists. Okay, all of these three things, okay, these are objects in R, and these objects are used to store data. Okay, so let's talk about array. Okay, array, for example, a matrix. Okay, matrix is an array. Okay, two-dimensional array. A matrix is a two-dimensional array in which the data is stored. Okay, in matrix this data is in form of numbers. Okay, so a data frame, on the contrary, is not a matrix. Okay, however, it can be represented in a rectangular setup or layout, but it's not a matrix. Okay, why it is not a matrix? Okay, the reason is because data frames, okay, the columns of data frames store different type of variables. Okay, while array contain only single type. Okay, array, this store only single type of what we say variables. Okay, while data frame can it stores different types of variables. Okay, so a data frame is a list of variables. Okay, it is a list of variables, each of same length but not of same type. Okay, while in matrix they are of the same type and same length. Okay, now I will do an example. Okay, in R to give us some data types. Okay, so let's go towards R. Okay, so now in the line number 35 I am going to use the iris data that is stored in the directory of it. Okay, and we will get the data from the directory, recall the data from the directory. Okay, so let's give it a code, okay, regarding the data that is stored in the name iris. Okay, So first, for example, I say sign of interrogation, and I say this iris, and execute it. So it will tell me what is this iris data. Okay, this will give us the description of data. Okay, so what is iris? Iris is a data frame with 150 cases, rows, and 5 variables or columns. These columns are named sepal length, sepal width, petal length, petal width, and species. Okay, so now we have the information about iris. Okay, now we will go towards the data that is stored in the name iris. Okay, for example, we want to have the names of the species. Okay, so I will say here names, and I will say iris. Okay, so iris is a data set. Okay, and these are the names. Okay, it is showing me all the things on here. Okay, so I will say iris. Okay, press enter. So when I run it, okay, I hope it will tell me all the things. Okay, so here are the names: sepal length, sepal width, petal length, petal width, and species. These are the 5 columns of it. Okay, and we know that it has 150 rows and 5 variables, 5 columns. So these are the 5 variables names. Okay, because all other data is in numbers and these kind of things. Only species, this is data frame. Okay, why data frame? Because the sepal length, sepal width, petal length, and petal width, these are numbers. These 4 are numbers, and the species is name. Okay, so this is combination of two variables, the character and the numbers. So it is data frame. Okay, so iris is a data frame. Okay, now we have names of it. Let do something else about it. Now, for example, we want the tables of these species. We are interested in this species, and we want to know how many species of each kind are there. Okay, so we can, if you don't know how to make the table, I will say sign of interrogation and table. So it will tell me exactly how can I make the tabulation. Okay, so I just have to write is table or as table or even table. Okay, all these 3 are, we are okay with that. Okay, so I will use the simple one. Okay, so let me put table and start the bracket. Okay, now here we have names of these species. Okay, so I will copy this along with these signs. Okay, because it is stored as it is. Okay, and when I run it, so it will give me species. It should give me species. Let me try without these. Okay, let me see what the problem is. Okay, so the problem is that the species is not found. Okay, so the species are stored in iris species. There is no variable species over here. Okay, these are stored in the iris species. Okay, so let me do it again. Table, okay, and I say iris, and the dollar sign, actually it gives me the context of which one you want to look for. Okay, so I say species, I'm looking for species. Okay, now when I run it, so it should give me all the species. Okay, so Setosa are 50, versicolor are 50, and virginica are also 50 in this data module. Okay, so these are 50, 50 and 50 species. Okay, each of these kinds, Setosa, this and virginica. Okay, so this is how you can use table, call any array or data frame. Okay, so now we will do matrices and arrays in this R language. Okay, so if I want to make an array, okay, which has no direction or dimension, okay, so I can use the ratio or colon to make that. Okay, so for example, I say that we have a variable b, okay, and I press control and negative, so it will assign the value. And in this assignment I say that b is assigned the value of an array from 1 to 24, for example. Okay, 1 colon 24. So what it will do is it will form an array randomly which has a value from varying from 1 to 24. 24 will be the highest value and 1 will be the lowest value. Okay, and it doesn't have any dimension. It will give you a random value, any random value between 1 and 24. Okay, now let's suppose we want to make a matrix. Okay, so for matrix, okay, you have to give it a dimension. By dimension we mean that it must have some number of columns or number of rows, for example. Okay, so for matrices we need to define the number of columns and number of rows also. So how we will do it? Let's do it. Okay, they're here. But before that, okay, let me give you the one-dimensional array. Okay, by one-dimensional array we mean that you give it only one dimension, like length of it. Okay, so length is one dimension. Okay, so if I suppose that I have some variable or dimension of something, like I say dimension, okay, dimension of x. Okay, so for example I say that dimension of c, okay, and I give it some value. Okay, and I say that it is the length of x. Okay, so what does it do? It's simply mean that the dimension of the c is the length of x. So this length x is only one dimension. So it is one dimensional array. It has only one dimension, and the dimension is the length of the x. Okay, x can be anything. Okay, so this is one dimensional array. Now to define a matrix, okay, we have to go to this matrix. Okay, now it gives me a syntax for it. Okay, it shows me data not applicable, like any random thing apply, given by R language, or you define the numbers. okay, then n rows, number of rows, number of columns, and so on. Okay, so I say that we have a matrix which has 2 rows and 3 columns. Okay, 2 rows and 2 by 3 matrix. Okay, but the elements of it, okay, it should be somewhere between 1 to 24. So I say here that the first thing is 1:24, comma, n row is equal to 2, comma, n column is equal to 3. So it will have 2 rows, 3 columns, and the elements of it will be randomly between 1 and 24. Okay, now if I execute it or run it, it is giving me a warning message, but the matrix is shown over here. So it has 2 rows, 1 and 2, and it has 3 columns, 1, 2 and 3, and these are the elements between it. So the elements are somewhere between 1 and 24. So first element is 1, second element is 3, 5, 2, 4 and 6. These are picked randomly. Okay, so we have a 2 cross 3 matrix being formed. Okay, so this is how we make the matrices. Okay, now if I want to make an array using concatenation, okay, I can also use the C method. Like here, this C, okay, if I say I want to make an array, okay, array not matrix, okay, so I want to make an array same size, 2 into 4 or 2 into 5 or 2 into 6 array, okay, but I want to make 2 of them, okay, then we can use the C operator. Okay, now for example I have selected a D variable and I am assigning the value to it an array. Okay, so the very first thing that I will do is I will use this assign operator and then I will use the array function, okay, because I want to make an array. Okay, so when I double click it, it will give me the syntax of it. So the same like matrix, it says data. Okay, so for example I use the same data that it is somewhere between 1 and 24, okay, comma, then it says the dimension length data and dimension names. Okay, so for that I will use the concatenation. Okay, so C, so it must have like for example 3 rows, 4 columns, and I want for example 4 different arrays. Okay, so the last one, it shows the number of arrays. Okay, this shows the number of rows, this shows the number of columns, and this, the last one, this shows the number of arrays that you want to make. Okay, so when I run it, let's suppose we run it. Okay, it didn't give me an array. I don't know what the problem is. Let me go through it again. Okay, it is giving me this problem. The array is not I used another thing, but it didn't form using the C. So there my syntax must be wrong. So let me use the syntax. So data I want to have from 1 to 24, comma, then it says the dimension length. Okay, 2. Let me see if I have used any of this in the last 42 lines. Okay, because I am getting this problem. I don't know what is happening over here. Okay, I should, I have, given this, assign this array to again to the variable d. Okay, so when I run it, it just shows this thing. Okay, it means that our code is correct according to the, because if there was any error, it should have given me error like this, but it is showing that array is being made, but it not be printed. Okay, so I need a print of it over here. Okay, so now to print it, I must return the value of this d over here. Okay, now when I say d and I run it, maybe now it gives me the array. Okay, now you see that we have two arrays. Okay, this is the first one. Okay, it has 3 rows and 4 columns, and these are random values between 1 and 24. And this is the second one. Okay, let me highlight the second one also. This is the second one. Okay, 1 2 3 1 2 3 4, and these are the values, and values are from 1 to 24. Okay, so that is how we can form a number of arrays using this concatenation C function or C operator. Okay, using the function of arrays. Okay, so that is how we do it. You just have to print it. We didn't print it earlier, so that is why it was giving us the problem. The array was doing the array thing, but it was not printing it, and we needed the print over here. Okay, so that is how we use the C operator to find and to make an array. Okay, using some random values, and the random values are here. Okay, now going towards some more examples. Okay, one thing that I want to mention here is that in the iris example, we made this $sign. Okay, so this $sign function is exact like we do it in the Excel. Okay, it selects only one thing. Okay, we were interested in species, so the $sign ensures that only species are picked. Okay, so that is why after the iris we put a $sign and then the column that we were interested in. Okay, I just wanted you to know about the $sign. Okay, now we will move forward to our next thing. Okay, in matrices we have one other thing. Okay, for example, I made a matrix A, okay, which is, for example, 3 cross 3 matrix. Okay, so it will have 3 columns and 3 rows. Okay, now in R, if I type our code A, this is the matrix, and square bracket I comma j. Okay, if I say for I say 2, and for j I say 3, so what it will show? It will show me only those elements, the second element in this matrix, in rows, second rows. Okay, so this is second row and the jth column. So it will show me this entity. Okay, second row and third column. So it will show me this entity. Okay, it will print only that value. We use square bracket to pick the value of a matrix element, okay, that we are interested in. Like we were interested in the second rows element and the third column element. Okay, so this was the interference point. Okay, this is the third column, this is the second row, so this was the corresponding element. So it will give us, print us this element, okay, whatever that is. Okay, now if I want to have only the ith, for example, I want to have the, for example, the second row elements, okay, and I keep this other one, the j, 0, I didn't type it. Okay, so it will give us only this second row. Okay, for example, second row, if we have a matrix over here which is 3 cross 3 and I have 1 2 3 4 5 6 7 8 9 as element, so it will type me 4 5 and 6. Okay, in the first one it will type me 6 only. Okay, because in the third column and in the second row we have 6 as a corresponding element. So the a square bracket 2 comma 3, it will show me the sixth element. Okay, and similarly here. Now if I want to have like something in the jth column, okay, so then I will not write the I, and I will write the j only. For example, the third, so it will show me the third column. The third column is 3 6 and 9, so it will show me 3 6 and 9 like this. Okay, so we use the square bracket to print the values that we are interested in. Okay, let me show it to you in the R language. Okay, in the R Studio. Okay, now suppose the matrix that we made over here, this one, okay, I assign it to some matrix like capital A. Okay, so I assign this matrix. Okay, I copy it over here and paste it over here. Okay, now it is assigned to A. What it will do is it will only make the the matrix, but it will not print it. Okay, so if I have to print it, I will say capital A, okay, and I will run it. Okay, object A not found. I must have used a capital A somewhere here. For example, I make from 1 to 6. Okay, now if I print it, okay, I have made a matrix from 1 to 6, okay, 2 rows and 3 columns, okay, and I have printed it in this form, okay. Here it has 3 columns, 2 rows, and the values are from 1 to 6, okay. Now I am interested in this second row and second column, 2 cross 2. So what I will do is I will type A, then I will go to square bracket, okay. Now I will say 2 comma 2, okay, and when I print it or run it, it will show me the value 4. Why it has returned value 4? Because 4 is in the second row and second column, so it has returned the value of 4. Now suppose I am interested in A square bracket, I leave the space of the row and I just want to have the second column, okay, then I run it. So it is showing me 3 4 value. Second column has value of 3 4, so it is showing me value of 3 4, okay. So that is how we can find any value that we are interested in from a matrix or from a complex matrix, okay. This is very simple, but you can do it for the complex ones. For example, the iris data that we showed earlier in the previous videos, this one in which we tabulated the iris species, okay. Similarly, we can use a square bracket to define any particular pinpoint, any particular data point that we are interested in, okay. We can use the same because their data is also in form of in data form, okay, kind of matrix. So we can pinpoint that using the square bracket. So square bracket is used whenever we have a matrix, okay, or a data array, and we want to pinpoint some specific point from a location, okay. Okay, now we come towards the list, okay. This is the another data form, okay. So list is actually an ordered collection of objects, okay. Ordered, it means it has a specific order, okay. So the members of the list can be of different types, okay. Members of list can be of different types. It means that they can be numbers, characters, okay, like men, women, etc., okay. And it can also be a logical, like true, false, etc., okay. So any data type applies here, okay. Lists are more general than the data frames, okay. Data frame in itself is a list with a class, okay. And the list can be created using the function list, okay. This is a function that is used in the R language, okay. List and brackets, okay. I will do an example regarding the list also. We will do an example, okay, in which we run 1000 Bernoulli trials of flipping a coin and then list the results, okay. So the number of trials is 1000, okay. The probability to be either head or tail is 0.5, okay. So probability is 0.5 to be either head or tail. Head is 1, tail is 0, okay. So let me first make the code for this whole scenario. So the very first thing that we do is we will define n as the number of trials, and we will assign the value of 1000 to it. Okay, so we have 1000 flippings, 1000 flips of the coins. Trials, number of trials is 1000. Okay, now the second thing that we need to do is that we have the probability of 0.5, so somehow we have to make sure that one coin is flipped n times. Okay, because n is 1000, so one coin is flipped 1000 times, and with the probability of 0.5 we are getting the result of the flips. Okay, and the generator that we will be using is the binomial generator because it follows the binomial distribution. Okay, so we will be using a random binomial distribution. Okay, so let's suppose we have another variable, for example s. Okay, and we assign the value to it as the R binomial, random binomial function. Now it says n. Okay, we have already defined n, so I will put as it is n, comma, then it says size. Okay, so we have only one coin, so size is 1, and then probability is 0.5. Okay, now when I enter it, now I want to table this s, these trials. Okay, so it gives me how many of them are heads and how many of them are tails. Okay, so let me use the table function, and I need to table s. Okay, so when I execute it, for example, here it says s is not found because I haven't used this, so I need to select all these three. Okay, because we have n over here, but n is defined as in line number 49. So if I only select these two, it will say n is not defined. Okay, so I am gonna do it from 49 to 51 and then execute it. So let's see what happens. Okay, now it is giving me that the number of zeros are 488 and the number of ones are 512. It means that number of heads is 512, number of tails is 488. Okay, now it has tabulated it. Okay, now after this we are going to list it. Now if I want to list the first 30 observations, okay, of heads, so I have to use the function head. Okay, and here I have stored it in s, all the trials, so I will say s, comma, and for example 30, so it will show me all the 30 trials. Okay, these are the 30 trials. Okay, okay, so now similarly we can do a lot of things with that. Okay, but the main thing was to use the some specific experiment and table it. Okay, make a list of it. Okay, so now I will move towards the problems that were given by the teacher. Okay, so here an example 1.8. Okay, what we will do in this example is that we need to create a list. We will use the list option or function. We will use the list function to assign rows and column names in a matrix and display it or print it. in R language. Okay, so think of this as a whole process, okay, starting from scratch. So I need you to focus on these things. If there is a question about it in the exam, so you are able to tackle it. Okay, so in order to assign rows and column names, first you have to make a matrix. Okay, so the very first point that we will do is to make a matrix. Okay, B is to assign a variable to this matrix. Okay, now in this make a matrix, what we will do is a matrix has 3 components in measure. Okay, a matrix has 3 components in measure. Okay, what are these 3 components? The very first thing is the values or elements. So in a matrix you have to define the values or elements. Okay, number 2 is the number of rows, and the number 3 is the number of columns. Okay, I need you to understand these things. Okay, for example, if you want to define a matrix in R, we have to define 3 components: the values of the elements, okay, like we have a matrix in this form. Okay, these are the number of rows, these are the number of columns. So this is a 3 cross 3 matrix. Okay, and these are the values of the elements. It will have 9 elements, okay, in total. So in R you have to define the size and the elements. Okay, so for this we have a matrix function in R, which we will use to make a matrix. Okay, now to define the values of these elements, okay, we will have the, let me show you in the R studio environment, okay, so that you understand it properly. Okay, so when we actually type matrix and these brackets, okay, it will give us a syntax. Okay, syntax is the way to define something in any language. Okay, so the syntax is to give, the very first thing is the elements, okay, then number of rows, comma, number of columns. Okay, this is the syntax of it. Okay, so this is how we define a matrix. Okay, and to assign this matrix, okay, to any variable, for example, we choose variable a. Okay, so I will use this assign, which is alternate key plus negative. Okay, so I will type a, alternate plus negative, and then I will type matrix and this brackets, so it will give me a syntax. So in syntax I need to define the elements, rows and columns, so it will make a matrix and assign it to a variable a. Okay, then after this we need to give the dimension names. Okay, these are the dimensions, the number of rows, this, and columns. Okay, so if you need to name, for example, I want to name this, okay, like C, D, E, and I want to name this like F, G and H. Okay, so using the dim names, which is a function of our program, okay, we can give names to these number of the rows and columns, okay, and then we can print this a using a function only, okay, and it will give us exactly like this matrix, okay. So let's do it in the R program, R studio environment, okay. Okay, so we are back into the R studio, okay. So the very first thing to define a matrix, okay, is to assign a variable to that matrix, okay, because you have to print it after all. If you do not assign any variable to a matrix, you cannot print it, okay. So the very first thing is that I need to define a variable. For example, here we define the variable a, okay, and then I press alternate key plus negative, so it will make the assignment operator, okay. So a is assigned the value of, now I will place the function of the matrix, okay. So when I do this, how I did it, let me show you here, okay. Okay, I deleted that, okay. I did that like this, shift key plus this opening bracket, okay. So it gives us this, okay, and in the same way it gives us this syntax. The first syntax is data. By data it means the elements, okay, what are the value of the elements, then number of rows, number of columns, and dimension names, okay. So what I can do over here is I will do it step by step, okay. So to define the elements, we will use here the uniform distribution, some random numbers that have the uniform distribution. So for that we have a function called RUnif, RUNIF. So RUNIF, and again the brackets, okay. So when I open the brackets, okay, it gives me to give it n, the minimum value and the maximum value, n, minimum value and maximum value. We do not need to do the exact the same way, okay. So we just give it n. Now for example, we want to create 2 cross 2 matrix, so the n will be 4. When we want to form the 4 cross 2 matrix or 2 cross 4 matrix, the n will be 8, okay. When we want to form 3 cross 3 matrix, the n will be 9, okay. So in this specific one we want to create, for example, a 4 cross 2 matrix, 4 rows and 2 columns, so this n value is 8, okay. Then I take it out of this bracket and press comma, okay, because now I am in the matrix 1. I am done with the run this RUnif, okay. I am not giving it the maximum value and minimum value. If you want to give it the maximum value or minimum value, you can also, you know, do it like 0, 1, 1 and 12 and so on, okay. You can do it that way, but I want the system, okay, to make the matrix whatever the values are, but the values should have the uniform distribution and the value should be random, okay. So I did the RUnif, okay, random uniform distribution, and the total number of values are 8, because we want to create 4 cross 2 matrix, 4 rows and 2 columns. Okay, and after that I will place comma, and after comma I will go into the matrix syntax. Okay, and in the matrix syntax, the first one was element, so I defined the element using the R uniform. Okay, now the second one was the number of rows and the number of columns. So the number of rows are 4 and the number of columns are 2. Okay, and I press enter. So now this command, it makes a matrix with uniform the members are elements which are 8 in number and have uniform distribution at random. Okay, and it has 4 rows and 2 columns. Okay, now that we have made the matrix, okay, I will now have the dimension names to it. Okay, so what we will use is, we will use the dim names. Okay, for example, I do not know how to do the dim names, so I can I can do it this way. Okay, when I place, because dim name is a function, so for function we use the double signs. Okay, double sign of interrogation. So when I place double sign of interrogation dim names and close bracket, it gives me all the results related to the dim names. So here I can have the proper way to define the dim names. Okay, I want into the matrix one. Okay, so I want to have this dim names. Okay, and it should give me a syntax of it. When I press the bracket, okay, it says only X. Okay, dim names, and I started the bracket and it says X. Okay, so here instead of X we have the matrix assigned as the value of the variable A. So I will press A over here. Okay, and to these dimensions, what I want to do is, I want to assign a list. Okay, we will use the list option. Okay, to define the dimension names of the matrix A. Okay, so now in this list we have 2 types of data. Okay, the rows and the columns. So for the rows, if you want to name them or number them, okay, we can do it using the ratio thing, this thing, ratio. Okay, or columns. Okay, and for the columns we will use the concatenation C. Okay, because we have instead of numbers we will have what we say, alphabets, X, Y, or things like that. So I would say letters from 1 to 4. Okay, this is for the X value, the number of rows. Okay, So it will number the rows 1, 2, 3, 4 like this. Okay, now we place a comma, and after comma I need to define the columns. So for columns we will use the concatenation C, and we will name them X, comma, Y. Okay, and press enter. Now I need to print this information. Okay, to print this information I need to press A and I need to run this. Object N not found. Let me see what the problem is. Okay, I press A and then I select all these, because all these are related, so just A would not work. Okay, so then I press run. Okay, it is giving me an error that the letters 1 to 4 could not find function letters. Okay, so let me go through this again, and here is some okay, the letter function is not there. I don't know why it is not there. Maybe our directory, the current directory that we have here of the functions, it does not support it, or we have not imported all the directory over here. So let's do it another way. Okay, I say that I do not want to name the rows. Okay, and just want to name the columns X and Y. Okay, now you see we have a result over here. Okay, it is listing X and Y, giving us random numbers for each element. Okay, 2 cross 4, 8 total number of elements randomly. Okay, and giving us 1, 2, 3, 4 as the rows values. Okay, at random. Okay, now if instead of this, I want to have the maximum and minimum value. Okay, for example, I say that the minimum value is 1 and the maximum value is 5. Okay, let's see what does it do then. Okay, now it has changed the results. Okay, X, Y, now the results are changed. Okay, so the minimum value is 1 over here and maximum is 5, so it will be 20 between 1 and 5. Okay, it is giving us random values. Okay, so that is how you can use the R uniform function to define the matrix, and then the list function to define the rows and columns dimension names, and then print it here in the console. Okay, this is example 1.8. Okay, one other way, because we haven't tackled the the rows names over here properly. Okay, so if I want to name the rows names, what I can use is I can use the row dot names, okay, this function, row names. Similarly, we can use the column names, okay, so row names, okay, and it says x. So by x means the name of the matrix. So the name of the matrix is, it is assigned into variable a, so I can say a, okay. So after assigning it to a, if I press Ctrl and negative, it assigns the row names, and I can use the list function, okay, to define the rows. Now we have 4 rows over here, okay, because the matrix is 4 cross 2, so we have 4, for example. So I place the, when we define a name actually, so it must be in this apostrophe double column, whatever the sign is, okay, it must be in this, because we want the exact name over here, okay, this is for the exact thing to be pasted over here, okay. So for example, we want to have north, west, east and south, okay, so I place capital N, comma, again the same signs, W, comma, again the same signs, south, okay, and same sign, east, okay. Now if I run it, what does it shows? Now it shows north, west, south, east, x and y to all of it. So now the rows are also named. We have the dimension names, okay. Any matrix has 3 dimensions actually, okay. The number of rows, number of columns, okay, and the third dimension is slice, okay, if we have multi-layer matrices, okay. So we have named both of the dimensions. That is how you can do it the other way. We can also have the row column names, okay. For example, I say column names, okay, and I say A, okay, and it assign this columns A to a list, okay, and I say X, comma Y. So it will do the same job as this one, the upper one, the second line, okay. So we can either use this in one line, or we can use these other 2 lines, okay, to define the column names and row names. So both are acceptable, both are okay. You can do either of these things, okay. And beside this, if you do not want to have the numbers as random uniform, you can have the random binomial and so many of the distributions at random, okay. That is also an option, you can do any of them, but random uniform is something that we use often, most often, okay.